Hello, everyone. My name is Louis Russell, and I'll be your host for today's episode of Swine Trends. Feed safety and the potential for viral contamination of feed are issues that are on everyone's mind today. The feed chain today is global and it is complex. Our pig feeds include ingredients sourced from around the world, including regions where reportable diseases like ASF can be or are endemic. Developing effective policies to mitigate those risks is a challenging task, but it's essential that this issue is addressed. Today, we're joined by Dr. Jerry Shurson from the University of Minnesota. He's a leading expert in the area and has written extensively and spoken about these concerns. Jerry, welcome, and thank you for joining us.
Well, thanks very much, Louis. It's great to be with you today.
Jerry, I think we can all agree that the feed chain today is extensive and it's complex. It can be overwhelming to consider all the points along the chain where contamination can potentially occur, starting from harvest to manufacturing of additives, transportation, finally to feed manufacturing and delivery of the feed to the farm. However, like a lot of complex issues, I believe the problem can be addressed if we compartmentalize and segment and identify high risk or high probability events that occur within the process. Could you share your perspective on the feed chain and explain how you approach identifying high probability events?
You know, I often mention when I have the opportunity to share perspectives with various audiences that I consider this whole topic as a new frontier. In fact, in some ways, it's like the wild, wild west. We're learning as we're going, but there's a lot of unknowns. There's a lot of uncertainty. First of all, I think it's important for everybody to remember or recognize that there's not a lot of direct evidence showing that contaminated feed causes disease in pigs or animals. We have a lot of really nice studies, experimental evidence where we have purposely inoculated feed ingredients and fed them to pigs and demonstrated infection in most cases. But when it comes down to direct evidence of the likelihood of this occurring in the real world, there's a lot of uncertainty. And part of the challenge that we have is we don't really have a system in place, Louis, that's global in nature, even national, that allows us to measure and monitor and prevent and control contamination. We don't have any commercial laboratories like we do for nutrient analysis in the feed industry for viruses that are capable of analyzing feed samples or do it on a routine basis, whether it's commercial labs or diagnostic laboratories at veterinary colleges across the country or even government labs. And even if we did, I often remind people that there are a lot of different types of assays that have been used in our experimental work, and they've been around for a long time. Things like TCID50 and HAD assays and PCR and other kinds of things. But we have to remember that all of these assays have limitations. And much of what we're trying to do is figure out, first of all, is a feed ingredient contaminated? And if so, what is the concentration? Is the virus viable? And is it in a form that can be infectious if we feed it to pigs? And so I often like to talk about and use the idea that we need to see the big picture. This is a systems problem. And I like the way you kind of led into this question of compartmentalizing and identifying parts of the whole. Yes, we need to do that, but we also need to see the big picture and put all these pieces together and look at the entire chain and look at what are the main hazards that we have to consider.
Well, I think those comments are very appropriate, and I agree with you. It is a very big picture. The feed chain is extensive, and we have to be able to break it down into bite-sized pieces, and then identify these high-risk events and not just chase after things that may be easy to do, but won't have a major impact on reducing risk. So I agree with you. Over the last couple of years, there have been a number of risk assessments that have been conducted and published. For example, the European Feed Safety Authority, EFSA, did a pretty extensive risk assessment looking at feed ingredients that are used in European feeds and tried to assess the risk of spreading ASF through these feeds. Your laboratory has published a number of papers over the last few years looking at the risk of spreading ASF and other diseases through feed. Are there some insights that we can draw from these assessments that we could use to help shape safety policy today?
Well, I think there are. And as in some of my beginning comments, I just want to emphasize again, and you're probably going to hear me say this several times because it truly is the current state of what we know today, and that there's a lot of uncertainty. And risk assessments can be really useful tools to complement our hazard analysis and risk-based control feed safety systems that all of our feed mills are required and feed manufacturers are required to follow in our feed ingredient or feed manufacturing processes. But part of the problem that we have, and I've summarized in actually a review paper that's been published a couple of years ago by our team, Declan Schroeder and Pedro Uriola were part of this work, and the papers really focused on not only biosecurity, which I think is part of our topic today, but also on mitigation strategies and where I think risk assessments fit in. And one of the challenges that we have and many of the studies that we reviewed in that paper are, first of all, some of them are qualitative and not quantitative. And what I mean by that is we really need quantitative risk assessments, those that can give us a calculation of probability or the likelihood of contamination at different stages of the supply chain. And again, recognizing some of our work, Rachel Shambaugh, one of our postdocs now and former PhD students, did a really nice study asking the question, what is the likelihood of importing organic soy or organic corn from countries that are endemic with African swine fever virus into the United States? And she came up with some quantitative estimates of probability. The probability is not zero, but it's somewhere between once every 25 to 5,000 years, depending on the ingredient and depending on the condition. And you may wonder, well, once every 25 to 5,000 years, that's a pretty big range. And that's a long period of time or a low frequency. And I think what that tells us is that we use the best available data to make that calculation, but because there is such a huge gap or lack of data and a lot of uncertainty, we have these huge estimates, huge range in estimates and a lot of uncertainty. So I think it's important that whether we're researchers thinking about conducting a risk assessment or whether we're practitioners and people in the feed industry trying to apply that information, that we understand that there's a lot of uncertainty in this new frontier of swine viruses and feed ingredients. These estimates need to be ingredient specific, and they need to be virus specific. People forget or maybe don't understand that PED virus is an RNA virus and behaves very differently in its survival and inactivation in feed ingredients than ASF, for example, which is a double-stranded DNA megavirus. And soybean meal survival of some of these viruses is different than animal products, and so we need to find better ways of quantifying these, filling in some of these missing data and knowledge gaps. And I think standardizing the methodology of measurement would be really helpful. Lewis, I know I'm kind of getting long-winded here, but let me give you an example of what I'm talking about. One of the very first and useful studies was published, and it showed half-life survival or half-life calculations of soybean meal contaminated with virus. And although that kind of got us thinking about this whole business about storage stability or storage inactivation of feed ingredients, it's really difficult to interpret data expressed as a half-life, especially if we're trying to calculate, and I'm going to use some technical terms now, D values, which is the time required to reduce the concentration of a virus in a feed ingredient by 1 log. D values give us something meaningful. It allows us as a feed manufacturer or somebody working in a feed mill to say, well, if I apply this amount of time and temperature, or if I add this chemical mitigant to my feed ingredient, I can expect the concentration to be reduced by 1 log during this period of time. Those kinds of methodologies are really missing or lacking in a lot of our risk assessment. And so, those are just, a few of the examples. More recently, we've, which I was really pleased to be part of. I think this is a really forward-thinking, very innovative, and very leading way of thinking about risk assessment, Lewis. And you remember the work that we collaborated with your team at APC on with quantifying the performance objective of feed safety in spray-dried plasma for PED virus and African swine fever virus. And I think that's the direction we need to be going with all feed ingredients, not just animal-based byproducts or plasma in this case, but using that feed safety objective. And for people that may not be familiar with it, the food industry is far ahead of where we are in the feed industry. And we've got to reconcile or shore that up, in my opinion, because even though I've said number of times that the likelihood of virus contamination in feed ingredients is not zero, but it's probably not as much as what many people have led us to believe, or many people think. And so one way to go about this is to use a food safety objective or adopt practices that are used in the food industry, which are much more rigid, much more, I think, applicable to what we're talking about here with virus transmission. And so a performance objective specifies the maximum concentration of a hazard, such as a virus, that's allowed at a certain step or set of steps in a food or feed production process, which helps ensure that a food safety objective is met, which is essentially saying that a food safety objective is the maximum amount of a virus in feed or a finished food product at the point of consumption. So you were talking earlier, Lewis, about compartmentalizing or thinking about steps in the food supply chain. And I think our feed manufacturers like APC, like our soy crushers, like our rendered animal byproduct producers, and many others in the byproduct, could even be DDGS for that matter, should be thinking about implementing these performance objectives around the process, compartmentalized and showing, okay, from procurement to final product, before it's shipped out of our door, down the food chain to end up in a pig feeder, did we do our job? What are the associated risks? And I think moving into that type of mindset and that kind of approach, which we have a lot of experience in the food industry of doing this, I think that could really help us a lot, along with some of the other comments that I've made.
I appreciate the comments, and you're right. The performance objective, the idea does come from the food industry. And APC, the parent company of APC, we also have food companies as part of the LGI family. So we spend time talking with our coworkers in the food on their food side. And that's where the idea of the performance objective, where it originally came from. And we were trying to adapt some of their principles to our manufacturing process. And I think the other point is that as a manufacturer, I can control this segment of the food chain. Once it leaves the manufacturer's location, moves further into the food chain, then it becomes part of that chain, and the manufacturer loses some of that control. But we can do what we can while it's part of our process. I like the other comment that you had early on, contrasting a qualitative versus a quantitative risk assessment. Because as I think about food safety, I think being able to prioritize the high probability events versus a low probability event allows us to focus limited resources toward a potential event that, if we can mitigate the risk at that point, we could have a major impact on overall food safety, as opposed to putting a lot of resources against a lower probability event or an event that wouldn't have as big an impact on the overall risk. You have talked a little bit about or mentioned the plasma and feed ingredients of animal origin. And there has been a lot of discussion recently about the risk of animal-derived feed ingredients. And there's been some discussion in the industry that maybe we should just ban all animal proteins from the feed chain. Or other groups have talked about the potential for a species-to-species ban as an important risk mitigation step. The renders and the spray dryers, like you alluded to, have invested a lot of time and resources trying to understand the manufacturing process and to implement additional steps in the manufacturing process. Well, we've got control of it that mitigate those risks. For example, a lot of the processes today are closed processes. They're continuous flow. They're computer controlled, which mitigates the risk of an unrecognized equipment failure. In your view, do animal feed ingredients pose a greater risk of viral contamination? And if so, what policies should the feed industry implement to mitigate those risks?
I think it's a great question. And maybe before I answer that directly, Lewis, let me just make a comment that I know you and perhaps others in the audience listening to this podcast know that I also spend a lot of time in a couple of other areas, circular feed and food systems and sustainability practices of food animal production and the role of feed and feed ingredients in more of a sustainable transformation that I think the industry is trying to go through right now. And along with that, how do we repurpose? How do we recycle nutrients and food waste, food loss and waste? And I consider plasma, and I think the classical definition of plasma, it is a food loss, just like rendered animal byproducts are part of our food loss component. And that's a huge problem in our sustainability efforts right now that really needs to be addressed. And so where I'm going with this story is that we cannot afford not to use animal-derived food waste products like plasma, like rendered animal byproducts, and have a sustainable livestock production system. I think we also have to remember that many of these products are very highly digestible nutrient and energy sources. They contain functional components immunoglobulins, for example, in plasma and other really valuable immune system benefit factors that studies have demonstrated some wonderful benefits in terms of reducing the mortality rates, reducing the adverse effects of disease challenges, virus challenges, PED challenges in pigs. And more recently, some of my favorite work that the team in the ASF team in Spain, Blasquez and Pujols and those folks have demonstrated that when you feed ingredients like plasma to pigs that have been vaccinated with the ASF vaccine, it actually enhances the efficacy. So again, I know these are somewhat unrelated to your overall question, but my comment earlier about we need to see the big picture and the huge impact, the huge positive impact that rendered animal byproducts and plasma have on environmental sustainability of livestock production, pig production in particular, and these functional benefits that we get from using functional ingredients like plasma, I think need to be part of this overall package. So to get to your direct question of, is there a higher risk of viral contamination of animal-derived ingredients compared to plant-based? I think the simple answer is there's a lot of misperceptions and misunderstanding because we don't know, because we don't measure, in the feed industry and in the real world, what is the prevalence? What is the concentration of rendered animal byproducts versus corn and soybean meal? We don't know. The perception has been that because it's animal derived and animals have viruses and plants don't, that there's a greater risk. But I think, as you've described, when we think about all the processes that are being used and all the modifications that were used to upgrade rendering facilities and production processes for spray-dried plasma, for example, and so on, they're far more advanced than many of our grain processing technologies with more time and temperature exposure if they are contaminated with virus. I want to remind you, and you probably remember this work, which I think we published, maybe 5 to 7 years ago. Nikki Trudeau, this is part of her master's work working with Sagar Goyal in our group. We demonstrated that actually, if you spike feed ingredients with the PED virus, and plasma was included in this, and we had corn and soybean meal and DDGS and I think blood meal and meat meal and some other ingredients as well. Actually, soybean meal and DDGS required greater inactivation time for the PED virus than did the animal-based byproducts. And so we don't understand what characteristics of feed ingredient matrices allow certain viruses to survive longer than others. Once we figure that out, that'll help us, I think, a lot in figuring out better mitigation strategies. But I think it's really short-sighted and to automatically assume that animal-derived feed ingredients would be more likely than plant-based ingredients to have contamination. I think the only concern that we really have, and this gets into the work that I do in the food waste area, Lewis, all of the major feed safety concerns we have, prions for BSE, bovine spongiform encephalopathy, part of the mad cow thing that has occurred in the past, which led to our ruminant feed ban that exists today in the US and in Europe and other countries. That still makes sense because, it takes a pretty high temperature, fair bit of pressure and time to truly inactivate those prions. And so that probably makes sense, not feeding ruminant-based meat and bone meal back to ruminants, but it certainly doesn't have any concern if we're going to feed ruminant-based meat and bone meal to pigs and poultry, cross species. The other area that we're learning more about based on some of the recent work, I think that you've alluded to in the past of from our team of using a surrogate virus for African swine fever virus, is that we're learning that some of our previous assumptions of time and temperature inactivation for that African swine fever virus are probably a lot higher than what we originally thought, and we need to learn more about this. But when we think about the spray drying process in plasma, the rendering process for all the other animal-based byproducts, time and temperature that's used, they're all of these other viruses, whether they're swine viruses, avian viruses, with the exception of those two examples, are totally inactivated. We don't have any concerns about those. So part of this just speaks to the value of research and science. Of all the work we've done in this space and all the literature that we reviewed on various viruses and feed ingredients, spray-dried plasma is probably the most researched feed ingredient of anything out there in the global feed industry. And that's a good thing. We should have a lot of confidence in the feed safety surrounding it.
Well, I think the example you bring up, BSE and the prion, I think that's a good example of the importance of understanding the potential contaminant, the pathogen, and each pathogen can have a very, very different stability profile, inactivation profile. And I agree, prions are very resistant to heat, very resistant to virucidal compounds or antibacterial compounds. It's a very stable entity. And because of that, then the feed ban or the ban of exclusion of high-risk materials, the SRM material, makes a lot more sense. It's appropriate for that type of a pathogen. Other pathogens don't. It's not appropriate to apply those same rules to other types of pathogens.
Yeah.
So, and different matrices, different ingredients, the stability, we've seen that is very different. When I think of viral contamination, or when I think of viral contamination in the feed, I think that, or at least as I think about it, the risk of contamination, the risk of contaminating an ingredient or a feed increases significantly whenever the feed chain and the animal chain cross. And by the animal chain, I'm thinking live animals, manure, bedding, or other contaminated material from a live animal. Whenever the feed chain or the feed ingredient crosses paths with a live animal, that's when we have a really high probability or a high risk event. Would you agree with this? And does that give us some insight on where we should be directing and focusing resources that could significantly reduce the risk of feed contamination? And are there any examples that might come to mind?
I basically agree with that, Louis. When we expand it beyond, the direct live animal contact to include manure and bedding, dirty boots, clothing, and hands of
Yes.
whether it's truck drivers or people working in feed mills, vehicles, trucks in particular. I'm thinking about a really nice study that was published a couple of years ago by Galvis. Cesar Corzo and our group at Minnesota was part of that study that showed that, when they asked the question, do animal-derived feed ingredients play a role in PRRS transmission among farms or virus transmission in general? Again, the same answer came back. 95+% of the transmission was pig movement, proximity of farms next to each other, driver and truck sanitation, transport, those kinds of things. So I agree with you. I think, keeping this in perspective and devoting attention where attention is needed is really the appropriate thing to do. I think we also have to remember that some viruses are airborne. Whether that's a role for contamination of feed ingredients, I don't think we really know. Certainly rodents, birds, insects, wild animals can be other potential concerns. And so going back to my previous comment earlier, compartmentalizing an ingredient manufacturing process is important, but it's the cross-contamination from all these lesser known or possible sources of viruses that kind of make us all crazy, and so I think that's what drives the need for developing much more comprehensive biosecurity protocols and plans that go up and down the entire feed chain. That includes, hopefully someday, these performance objectives that we're talking about from different feed ingredient suppliers going into commercial feed mills or integrated livestock farms. But certainly clean and dirty zones in feed mills, covering ingredient pits, one-way traffic control, truck and driver hygiene. I think those are areas that are not directly associated with an individual ingredient, but they play a role in this cross-contamination question that we struggle with. And so I think we need to be thinking about those as potential hot spots, let's call them, where we need to design some reasonable biosecurity plans around.
And I agree with you. In my mind, the events that you described, the trucks, dirty boots, clean, segregated areas in the feed mill, covering those are what I would refer to, or in my mind, I would think of them as high risk events or high probability events. Those are the, if we could use a CQI or continuous quality improvement term, those in my mind would be the big legs to focus our attention on. I agree. Recently, there's been quite a bit of discussion about holding feed ingredients at elevated temperatures for extended period of time. While that strategy can be effective, if you consider some of the low inclusion rate or lower volume ingredients, the obvious challenge of expanding that to complete feed, for example, would just be the infrastructure that would be required to hold and store 30, 40 days of complete feed. That was a big challenge. But are there other negatives? Are there other downsides that we need to think about as we consider holding and storing at an elevated temperature the ingredients that are our complete feeds or the ingredients that go into our pig feeds?
Well, there certainly are, and maybe before I list what those unintended consequences, as I think of them, might be, I think it's important that we recognize that, yes, extended holding time can be a partial inactivation strategy for viruses. We have to remember that we can't lump all swine viruses into the same pot and call them the same, because they're not. They all respond differently, and all feed ingredients, as I've kind of alluded to a couple times today in our conversation, some are, for reasons we don't understand, able to allow longer term survival of viruses than others. We have to keep that in mind relative to relying on this strategy as the be all end all of all of our biosecurity efforts, because it's not. I think we also have to recognize that we don't know what the initial concentration of a contaminated ingredient might be. And so depending on the ingredient, depending on the virus, depending on the time and temperature of storage, we don't know if there's enough inactivation to get it across the threshold so that when it's mixed with the other ingredients, assuming they're not contaminated, that by the time it ends up in the pig feeder, it doesn't cause disease. What we've learned recently, and we're about ready to submit a manuscript for publication in a journal. This is some research that was funded by the United Soybean Board, is where we used our surrogate virus for African swine fever virus, and we spiked corn, soybean meal, DDGS, corn fermented protein, soybean hulls, corn and soy-based ingredients that are commonly used in the feed industry. And we stored them up to 34 degrees Celsius. Now that's a pretty high temperature, probably not as high as where it gets in Southeast Asia, for example, or maybe in some of the southern states here in the United States during the summer months with a lot of humidity, but it's a pretty high temperature. And we stored these ingredients up to that temperature for 120 days. That's a long time, probably more than what most feed manufacturers are willing to commit their storage space to. And we saw very limited inactivation of that surrogate virus over that length of time and at that temperature. As a swine nutritionist, animal nutritionist, I'm concerned about storing ingredients at that length of time, at that temperature. And certainly we know that higher temperatures are needed to fully inactivate a whole variety of viruses, usually in the 70, 60, 70, 80 degrees Celsius range for 30 minutes. And so what often gets forgotten when these practices have been put in place, and they exist in here in the US and Canada and elsewhere, is that vitamins are really susceptible to temperature. Some are more susceptible than others, but we lose vitamin potency if we're talking about vitamin trace mineral premixes. We can also get protein and lipid oxidation. We don't know as much about protein oxidation, which of course is a concern for ingredients like spray dried plasma or rendered animal byproducts, but there is increasing evidence. We've been doing a little bit of work in this area, indicating that it contributes to oxidative stress if it's fed to animals. We certainly know a lot more about lipid oxidation, but both those two things can happen at these higher temperatures, especially if we've got humidity associated with it, if we've got appropriate levels of water activity in these ingredients, and we could see reductions in amino acid digestibility over time. And if we have moisture content in the 15% range, typically we think of 12% being pretty safe for long-term storage of grains and oilseed byproducts. But bacteria, spoilage, mold, and mycotoxins can also be potential unintended consequences. So here's an example, Louis. So let's see the big picture again. Yes, we're concerned about the potential contamination, and we want to store it at a somewhat high temperature for a long time to give us some confidence or provide some insurance that we're inactivating virus if it's there, which, by the way, we don't measure again. I'll remind you of that. But in doing so, we're likely having some detrimental effects on the nutritional value of the whole purpose of why we're doing this in the first place. And so let's keep our eye on the ball and see the big picture.
No, I appreciate those comments because I think you're very right. What we've seen in the literature, different matrix, different feed ingredients, different viruses will respond differently during storage conditions. The plasma producers, for example, have incorporated a holding period, a post-processing holding period into the manufacturing process. And we've looked at a handful of different viruses, but you're right. Some of them we may lose 2-3 logs during that holding period. Some of them we may lose 4 or 5 logs. So it depends on the virus and the matrix, and we don't want to end up with unintended damage to our feed ingredients. So it's important that we evaluate and understand. Well, thank you, Jerry, for your insight today and your comments. Are there any other final thoughts that you might have or closing comments as we wrap up?
The only thing that comes to mind, Lewis, is I really was amazed, surprised, I guess would be another way of saying it. A study that APC, your team sponsored a few years ago, which I thought was a really, and I think it's a really good way to maybe end our conversation for today, and that is feeding African swine fever virus contaminated plasma to pigs for 14 days in 2 separate experiments.
Mm-hmm.
And these were concentrations now that should have been high enough to cause infection, cause the pigs to get sick, but it didn't. I still go back and reread and read and reread the methodology and the results and try to figure out, how did this happen? But I think my interpretation, for what it's worth, is that it just tells us that we've got a lot to learn about virus contamination in ingredients, amount of infectious virus that's present, how do we measure it, how much is needed, how does it vary among our ingredients, all the things that we've kind of bounced around and talked about today. We got a lot of work to do and a lot to learn. And so I think it's a nice example to indicate that as I finished up my presentation at the Layman Conference this year, things are not always as they seem. And so let's keep working on helping the industry, helping us understand viruses in feed ingredients and what their relative risks might be.
Well, thank you. I think after today's discussion, I agree that it is a serious issue. There is a risk, but we need to develop feed safety programs that identify those high risk, high probability events, and then put policy in place that mitigate those and reduce that overall risk. I hope the discussion has been useful to everyone listening. And that's it for another episode of Swine Trends. Thank you for listening.
It's been a pleasure, Lewis.